Good afternoon, everyone. Thanks for taking the time to be with us here today. My name is Milind Desai, and this is Sachin Thakur. And over the next hour, we're going to talk about NSX. An hour does not do justice to this network virtualization platform. So all through the course of this presentation, there will be pointers to other sessions you can attend to get the next level of detail. The idea of this session is to get you familiar with the functionality that this product provides, the capabilities of the platform, and how the components kind of fit in to deliver the network virtualization platform that we talk about. So before we get started, why NSX? Why network virtualization? And so as we look at our customer base and our conversations with customers, customers desire flexibility. Flexibility in pooling their compute resources. Flexibility in designing software-based segmentation compute zones. Flexibility in addressing their workloads better from an IP addressing standpoint. Being able to provide self-service for the application at scale. Then there is security. Can we do security in a better way in the virtualized environment, especially with self-service coming into the forefront? And last but not the least, can we get the same experience both in my data center as well as I extend to the public cloud? All of this boils down to this one notion that Martin talked about. How can we get the operational model of a VM, the ability to create, delete, shrink, grow, snapshot, extend, things that you're used to doing with compute today, but now make that available for the network. That is the fundamental premise for this network virtualization platform. So when you look at NSX, it works with your existing infrastructure today. We can walk into any environment, and all we need is IP connectivity in your infrastructure. It works without any change to your physical infrastructure. We deploy the NSX software, which provides this operational model of a VM, through API, delivering a switch, a router, a firewall, a load balancer to the application on demand in minutes. That is what NSX can do for your application in your data center today. So your natural question is, what does NSX consist of? So from a capability standpoint, you have a fully functional layer 2 switch, flow-based marking, QoS, ACLs, all of that functionality built in, a fully functional logical router. When I talk about routing, I'm talking about east-west routing as well as north-south routing. And I'll get into a little bit detail as we get into slides further along. A distributed firewall that sits closest to the workload and runs at line rate. And then, of course, from application availability standpoint, providing a load balancer service that helps with application availability and performance. All of this combined with an API through any cloud management platform, running on any hypervisor, along with our partner ecosystem. So the key message here is NSX is a data center-wide platform. It's not just for vSphere, it's for any hypervisor and physical workloads, and it works with any cloud management system, vCloud Automation Center, OpenStack, CloudStack, or your vendor of choice, to deliver these functionality in software on demand. So from a component standpoint, right, when you look at vSphere, you deploy ESX, you deploy vCenter. What are the components that make this network virtualization platform? From a data plane standpoint, you all know the virtual switch. It leverages VDS, OVS, plus kernel modules that provide the fully distributed scale-out data plane at line rate. Right? So we're talking about line rate performance for all the functionality that we're talking about. And then you have the gateway functionality, which is a VM form factor, highly available, that allows you to connect from logical space to physical space. So as you go north-south from logical to physical, that is where the gateway comes into play. We have the controller. Think of the NSX controller as the brains of the operation. It decouples virtual network topology from physical. It knows all state of the topology at any given point in time. And it is, again, highly available and built on a scale-out architecture. So you can keep adding more nodes as you want more capacity, or if a node goes out, it redistributes the load to the other workloads. So it's a highly available scale-out controller in that regard. And it does not sit in the data path. That is a critical piece, right? It does not sit in the data path, so it's sitting out of band, providing this decoupling, providing this intelligence for running this network virtualization platform. You have the NSX manager. Think of it as a management plane which delivers an API, a UI service, and this API is REST API enabled, so you can program to it. And again, this is a highly available form factor delivered to deliver API services, which in turn interacts with cloud management systems. And we have direct integrations with things like vCloud Automation Center, OpenStack, CloudStack, and other such CMS, CMP systems. That does not mean you cannot use this platform without a cloud automation system. As you will see in the product demonstration, all of this is available through vSphere Web Client, so you can actually create networks and apply policies even in those environments where you don't need self-service. So how do we get started, right? The natural question is, we are in beta to be going GA in Q4. There's a hands-on lab, but how does one get started? How does one think about starting on this network virtualization journey? Like I said, you can leverage your existing infrastructure. How many here have IP connectivity in your data center today? Raise your hands. You're all ready for network virtualization, right? You're all ready for NSX. Nothing more is needed from a physical infrastructure standpoint. Step 2 is about deploying NSX from a software standpoint. And so we have mechanisms to deploy this software, and what we're going to do now is through demonstrations show you how easy it is to get started with NSX. So with that, Sachin is going to take over and walk you through some key elements of our deployment for NSX.
Sure, thanks, Milind. So basically what I'm going to quickly do is walk through some of the new functionalities here in the NSX product. And what you're going to see here is a simplified one-click deployment for the NSX solution. So unfortunately, last year, Milind and I, we did it all live, and we wanted to do that again this year, but the Wi-Fi, as you probably have seen, is a little spotty. So we're going to go with recordings here, but I'm going to walk you through it. And this is all available in the hands-on lab, so I'd encourage you to go check it out yourself. So as you see here, we have native integration for networking and security for the NSX product in the vSphere web client. And that's one of the big things here where we can get inline performance with NSX directly from the vSphere client. So we're going to get started and drill down into the networking and security tab here. And the first thing we need to do is install the bits. So we go ahead and click on installation. And we see a couple things here. The first is, as Milind mentioned, the heart of the product, the controller. Now, this is some of the technology that's come in via the Nicira acquisition. And we've integrated that into the NSX family here and created a single-click deployment for your controller. And you can deploy it in a highly available scale-out manner. Now, as you see here, I have one controller already deployed, but I'll walk you through a quick step to show how easy it is to scale this out. I'm not going to actually deploy it in this demo for the interest of time, but I'll walk you through all it takes. You just specify some compute, you specify a network to give it IP connectivity, and you're pretty much done. I'm choosing a compute cluster, I'm choosing a data store, I'm choosing a network, and an IP pool for giving it a static IP address, and that's it. That's all it takes to deploy a controller. NSX Manager will take care of the rest. Scale out the existing controller, redistribute all of the data that's there, and all of a sudden you have a highly available control cluster. Now the next piece is actually disseminating the bits into the hypervisor to provide that line rate NSX service at the hypervisor itself. So that can be firewalling, that can be the actual switching, it can be overlay networking. All of the components are actually sent down to the ESX host via the NSX manager. Now, those of you who are familiar with the former vCloud and networking security product may have seen some of these screens, and we've enhanced it here to actually allow some additional optimization. So in a single click here through the vSphere web client, I'm going to go ahead and install the bits.
And so this is the WIB where essentially we are putting the WIBs for kernel modules, for firewalling, routing, the overlay networks into the hypervisor itself and preparing the host for network virtualization, right? So it's as simple as preparing your clusters. You click the cluster and you say deploy, and it takes care of it from a deployment standpoint. So you could deploy 1 cluster, 3 clusters, 10 clusters in your vCenter topology in a matter of minutes. Right? So it's very powerful stuff. And again, this is the same interface that you're used to, which is the vSphere web client. Again, from the same console as you manage compute, you can start thinking about consuming networking and security.
Right, and another thing I'd want to point out here is, as you see here, there's a column here for the firewall. So that means as soon as you install these components, you have actually just created a distributed firewall at the click of a button. Now, you can go ahead and configure rules later on, and we'll walk through that as well. Now, the next thing we need to do is actually configure our overlay networking. So for VXLAN, for example, we need to configure our VTEPs. So as soon as we've pushed the bits down to the ESX hosts, we can go ahead and configure VXLAN in this case. Now, we've gotten a lot of feedback over the past year for a few requests from our customers. One of which was, well, why can't I have static IP addresses on my VTEPs? There was a requirement for DHCP. That's no longer the case. Now we have an ability to actually allow static IP addressing for your VMK NICs for the ESX host for your overlay networks. Now, if I unpause it here, another big request was your teaming mode. We wanted to enable multipathing. Now, those of you who may have blade chassis systems may have faced the pain of actually having to configure those chassis switches for overlay networking. With this capability, this should no longer be an issue. You'll be able to use all of the teaming modes that you're familiar with on the switching today, load-based teaming, MAC hash, IP hash, et cetera, with the click of a button. Now, as soon as we've done this, we actually want to pool our compute into what we're calling a transport zone. So those of you familiar with the previous terminology, this was known as a VDN scope. It's since been renamed a transport zone. And in this mode, we'll be able to say, well, I want to pool these compute clusters for my network. So as we see here, I've prepared compute cluster 1 and compute cluster 2, and we see the VTEPs are properly configured and everything's in a ready state. So we're going to go switch over to the transport zone and go ahead and create it. So I'm going to create my demo transport zone. I'm going to say it's leveraging the NSX controller because there's a key element here that wasn't there in the previous release. We're able to choose a control plane mode for our transport zone. Now, what does this mean? Previously, as you may have seen, VXLAN had a requirement for multicast in your network, whether it's L2 or PIM, if you're going across an L3. This is no longer the case. As you see here, we have three control plane modes. There's the multicast mode, which is kind of what was there in the previous version of the product. But we also have unicast mode and hybrid mode, which actually has some further optimization, leveraging the NSX controller depending on your physical topology. And Milind will cover that in just a minute here. So I'm going to go ahead here and choose unicast mode, since I don't want to have the requirement for multicast in my network. And I'm going to go ahead and choose the compute clusters I want to pool into this transport zone.
And remember my conversation about being able to create soft compute zones, which are elastic. You can grow and shrink. You can add clusters to this transport zone as your capacity needs grow, or you can remove things as your project goes off, right? So it's elastic in that nature, and the network constraints grow and shrink with your compute constraints. So that's the level of automation that we're talking about, where the network boundary is always aligned with the compute boundary, and while you're doing all these operations, your physical network is not touched. It's completely decoupled from your physical infrastructure to allow you to create these constructs in software.
Right, and that's pretty much it. We're done. We're ready for network virtualization. So I'm going to pass it back to Milind, and we'll see how we create networks in just a minute here.
So available through the vSphere web client, simplified deployment for all the different modules that we're talking about, and giving you the ability to create, like I said, software compute zones, which in turn allow you to consume applications and network services very easily, which brings us to step 3, which is consumption, right? He set this up, right? In front of you, he set up a topology. He got 2 clusters ready. We're ready for network virtualization on those clusters. You can now program logical networks, routers, firewall, load balancing on demand, and deploy it on those 2 clusters, again, with API, through UI, or through a cloud management system. It's really that simple. And if you look at what I mean by an application, we've been talking to a lot of customers. There are a few canonical topologies that come out. You either have multiple tiers, multiple networks, so each tier maps to its own distinct network, a load balancer, and firewalling between them. And when I'm talking about firewalling, I say the web network can only talk to the app network on port 1443. Right? And the web network can only talk to the outside world on port 443, and that's it. Right? So how can you create such simple policies and make that happen? The other model that you see is this notion of a flat network, a single network, and then putting all the tiers on the same network, and then using firewalling to microsegment the different tiers. These are the 2 canonical topologies that we see our customers deploy in typically. And all of this, like I said, can be fully automated through this interface, either UI, API, or cloud management system, right? You can build these application topologies, like I said, in software, on demand, and not only these, but other such topologies can be enabled. But these are the most common topologies that we've seen in our customer base. So let's take a deeper look into what this actually means. So I'm not going to spend time on the virtues of why we need logical switching, but the basic essence is you can create networks on demand at scale as and when you wish, aligned to your application needs, without touching anything on the physical network. It works with your existing infrastructure, and you don't have to deal with VLANs. You don't have to deal with complex protocols running on the physical. This essentially leverages just IP connectivity and makes it happen, right? So from a performance standpoint, again, it's extremely performant, and it allows you the flexibility that you desire in your data center by pooling 3, 4, 7 compute nodes very seamlessly, again, as you need, as you desire, without having to go reprogram the entire data center. So when you look at this, and you saw this slide in the keynote where this notion of a network hypervisor, again, the reason I wanted to point this out was this is data center wide. We're talking about vSphere here, but this works across other hypervisors, KVM, Xen, and physical. And what you get is you can create these logical switches, and you can see in this case, I'm just showing you an L2 conversation that's happening across that switch, right? These switches can have flexible IP addressing. You can have private addressing. You can use NAT, and I'll talk about how that comes into play, or routable IP addressing. So all the flexibility you desire from an IP addressing standpoint, and all the flexibility you desire from a compute standpoint. So with that, Sachin is going to walk you through how simple it is to create a logical switch in this new world.
Right, so now that we have our transport zone set up, we're going to actually dive back into the vSphere web client here and create a logical switch within this transport zone. So again, we go to the logical switches tab here in the vSphere web client, and we create a new demo switch. Now, the interesting part isn't actually creating the switch, where again, we have the control plane mode, which is inherited from the transport zone. But the more interesting part will be what we can do with this switch once it's created. So I've gone ahead and created this demo switch.
Just a minute. That is how simple it is, right? That is L2 connectivity across that transport zone, right there. Those 3 steps right there created that L2 connectivity across your transport zone, across that compute fabric that you desire.
Right. And so I didn't have to do much, right? I just specify a name and a description, and I go. Now we can get to the interesting bit. We can actually attach our services on top of the logical switch. We can connect an L2 gateway service, which at L2 will let us bridge this VXLAN out to a VLAN if we had that requirement. We can create a logical router, which will let us do distributed one-hop routing east-west. We can configure services. We can configure NAT, DHCP, firewalling, load balancing, VPN, all within the click of a button from the NSX manager here. We can configure a firewall, like Milan was mentioning, that's fully distributed at line rate at the VNIC closest to where the workloads are running. And so this is the types of things that we can do. But that's not all that's quite there. We can actually go take this a step further and say, well, we want to leverage some of our switching functionalities. So what we can actually do is leverage some of the functionalities of our switching platform. In this case, it's the distributed switch. And we can go ahead and attach a few virtual machines. And then we can actually go and configure things like QoS, DHCP, marking for system traffic, vMotion traffic, all at the click of a button through the vSphere web client, which is our single portal for networking and security here.
So what Sachin is
world.
showcasing over there is how easy it is to attach those VMs to this logical network. And he mentioned something very, in quick passing, the L2 bridge. It allows you to P2V your physical network. Your VM sitting on a VLAN can be migrated live into your logical space using vMotion and this layer 2 bridge technology that we have to get into logical space without changing, again, anything on your infrastructure. So this works not only for new applications, you can take existing applications and migrate them live as part of that construct. This is also part of the keynote tomorrow, so that's the reason we're not demonstrating this functionality right now. So you'll get to see this live as part of the keynote tomorrow, but that is the power of this platform. You can P2V your physical network and get that agility within minutes through this layer 2 bridge functionality.
Right.
So that's about switching. Routing, right? Today, if the app tier and the database tier are sitting on the same host, you have to go out to a physical router and come back in to complete that conversation. Imagine in your data center now, a lot of east-west traffic is taking place, right, between your different application tiers. That's the way new applications are designed. There's a lot more east-west traffic compared to north-south traffic. With NSX, all of that traffic is now hypervisor to hypervisor. So if 2 VMs are sitting on 2 different subnets and they need to talk to each other, that conversation is now localized within that hypervisor. So the routing functionality is embedded in the hypervisor to allow communication not only at layer 2, but also at layer 3. So that's one element of it. The natural question is, what else? We can also interface with physical routers and leverage traditional protocols like OSPF, BGP, ISIS, and do route protocol advertisements to the physical world. This gives you the flexibility that we talked about for IP addressing. Because in large enterprises, people don't like NAT. They don't like private IP addressing. So they need the routable network space. This allows you to create logical networks with routable IP space, again, without needing to go through hoops in terms of physical configuration, right? So fully distributed L2, fully distributed L3, with the ability to interface with traditional physical routers is what's available with NSX in this year. Now, this is also multi-tenant. So if you're a service provider or a multi-tenant enterprise, you can create one per tenant or one per application if you so desire, right? So it's fully flexible, again, REST API programmable, and gives you a lot of agility. So I'll take questions at the end about routing, so we'll take that in that regard. So again, it's fully distributed, and what it allows you to do, again, from a visualization standpoint, is we have a logical switch, which we saw before, and now you also have the L3 communication, as I mentioned, again, direct hypervisor to hypervisor, or if you're sitting on the same hypervisor, localized to that hypervisor, right? So it's fully distributed, and all the intelligence is in the software now at our layer. So from a demonstration standpoint, I think Sachin is going to highlight a few key things about how simple it is to configure some of this peering. And with that,
Sure. So there's a couple things I want to highlight here when it comes to logical routing. Now, as Milind mentioned, there's the ability to create a fully distributed logical router for your east-west connectivity, and there's the dynamic routing protocols. But we wanted to make sure that that operational model is still the same, regardless if you're using virtual networking or any other form of networking, right? So what I'm going to show here in this demo here is I'm going to have two gateway devices that are both NSX edge gateways that are deployed through software that are peered to one another to create that three-tier topology that Milind was describing earlier. And I'm going to show how easy it is to peer them together using a routing protocol such as OSPF, and then go drop into the CLI of these logical routers and actually see that they are peered, and we get our traditional ability to actually view the LSAs, et cetera. So I'm going to go ahead and drill deep again to the vSphere web client here. We're going to go to the Networking and Security tab. And now in this case, I've actually already configured OSPF and redistributed the routes in my topology. But if you want to actually give this a try yourself, I would recommend you to try the hands-on lab where you can actually deploy this thing and give it a try live in person.
And the natural question is, I'm a virtualization admin, and some of you are here in this room. Now do I need to worry about routing protocols and managing that element? This is one of those things where, you're going to start, as we talk about SDDC, it's not just about one domain. You're going to bring people together. And what we are starting to see in our customer base is the network teams and the compute teams are starting to work together. And this is where your network team can essentially help you peer to their physical router, a one-time setup, and get you going after that, right? So they can give you a big block of IP addresses that can peer with physical, and then you're off to the races. So it allows you that flexibility, but the teams will come together, and there will be some help and some coordination that you will make happen in your environment. And the early adopters are making those changes in their organization so that they can come together and deliver the value of SDDC, as Pat pointed out today.
Right. So in this topology here, I have a web network, an app network, and a DB network that are connected as logical interfaces to my distributed router. That's the one you see here as a logical router. Now, this logical router is peered to a services router, which is connected north-south to my data center. So what I'm going to quickly drill down into the logical router here and go into the global configuration, and we see that I've enabled OSPF. And you can see the area definition, you can see the forwarding address, the protocol address, all of the traditional things that you would expect when you're configuring OSPF in your network. And you can actually redistribute the routes for all the connected interfaces. So I've gone ahead and done that. And now to show you that it's actually connected, I'm actually going to drop in to the gateway CLI here, the logical router CLI, log in here.
And again, this is one of those functions as we have been interacting with our customer base and interacting with network admins in these accounts. This is where the network admins have actually kind of taken over this kind of role and are starting to use this gateway as that boundary of where the logical space meets the physical space, and starting to help design those elements in place, right? So I help you design the gateway, and the gateway pairs with my physical router. Inside the gateway and inside that compute zone, you have all the flexibility that you desire based on your application needs. That's one way to kind of start thinking about how you bring your team together in your own environment.
Right, so this will let you get the flexibility of those virtual workloads from an IP perspective that you desire without actually having to compromise anything from a functionality perspective. So what we're going to do here is run some of your traditional show commands to show you the IP route. We see that we have OSPF configured and it's peered. And I'm actually going to go do a show IP OSPF neighbor, and we're going to see that this is actually peered to the other router in the topology here, which is further upstream. And you can actually go into more advanced configurations as well, like you can look at the LSAs, and we can actually see statistics, et cetera, for OSPF here. So this is the power of what you can actually achieve from both a deployment perspective and a configuration and operational usability perspective using NSX.
Fully distributed L2, L3, peering with physical. What's next? Actually, which one are the slides? Oops. Security. Today, you implement security. Typically, again, it sits out of band. Your traffic is U-turn, there's hairpinning, and you're not potentially protecting all the workloads that you so desire in your environment. What we are doing with NSX is, as we mentioned earlier, the firewall, a fully stateful firewall, is implemented in the hypervisor itself. Its line rate, right, 10 plus gigabits per second. It includes identity, so you can create rules based on identity, as well as it has all the other needed elements from an automation standpoint. As I said, you could say a web network can only talk to an app network on port 1443. When a VM arrives in that web network, it auto-inherits that property. You, nor the security admin, had to go do anything special to get that workload up and running. Right? Full automation implemented closest to the application, again, within minutes. Right? So that is the power of NSX. Firewalling is now embedded closest to the application in the hypervisor and implemented there in the stateful manner. And the way we do rule management and rule configuration is greatly simplified versus traditional firewalling constructs where you use IP addressing. So this greatly simplifies fully distributed L2, L3 firewall. Imagine you've got 4 racks of compute, everything is flowing hypervisor to hypervisor from a L2, L3 firewall standpoint. Can be automated and with full visibility into that infrastructure. From a performance standpoint, this is, like I said, if you start pooling your compute, you get 10 gigabits per host times 30 is 30 terabits, right? So that's the idea of the notion of firewalling. So what does this look like again? You firewall before you actually go in, so you can actually block your packets before it goes to a different switch. So because it's in the hypervisor, if a conversation doesn't need to take place, it's blocked right at the source and the packet never leaves the host. Or if two workloads that need to talk to each other are locally protected. A very common term for this, even in the same logical network, is zero trust. You can implement zero trust security with this firewall in your data center. I'm going to go on to load balancing, and from a load balancing standpoint, think about cloud load balancing, right? We are not going after the traditional load balancing notion, but this is a cloud load balancer. You can deploy it in one-arm mode, or you can deploy it inline. It supports HTTP, HTTPS, as well as TCP. It does SSL termination. It has layer 7 rule management, X forward header, cookie persistence, all the rich functionality that we've added this year. But again, think of it from a cloud load balancing perspective, things that people do when they go to public clouds in that regard. And so what we're starting to see is this is becoming a common use case, especially for customers who are looking at DevOps style scenarios, where they're starting to use this load balancer as their first tier for application availability. This functionality, again, is part of NSX. There's a dedicated session just on this topic that you can get a lot more detail on. So all this is great. You can create switches, routers, firewall, load balancing in software. It's all application specific. It's all magic. It will all work, and everything will be great. I will tell you the first thing, the first conversation that happens is, how will I operate this environment? I've got an operations team. How will they function? So when we think about operations, there is the traditional tools. We export NetFlow records. You can do RSpan, ERSpan, and other capabilities to look into this logical space. Right? So the traditional tools are being enabled by us that you can use to monitor these virtual networks just the same way you monitor physical networks today. The second layer is our layer, the network virtualization layer. What is the health of that layer? Right? Are the conversations, are the different endpoints communicating? Are the different networks up and running? We provide full visibility into that at any given point in time. You know what networks are up, what hosts are down. All of that visibility is available in our layer. The third level is what you call virtual plus physical. We have tools that are starting to enable this notion across virtual and physical topologies, and we are starting to use a next set of tools like Log Insight, vCenter operations, as well as other pre-existing tools to provide a different way to operate the data center moving forward. So using syslog and other techniques, we are able to dump data into these log management systems to show analytics between virtual and physical, through vCenter operations to show the ability of what's happening across virtual and physical infrastructure. So from an operations standpoint, like I said, full visibility into logical space, full visibility into the health of the network, and very good operational knowledge of difference between virtual and physical and what's going on from that standpoint. So we thought we would show some elements of what's going on which is unique to our environment, right? Unique to NSX. We can do flow-based monitoring. Sachin is going to show that. We can actually show you who's accessing what service within the application, which is server access monitoring. Full visibility into what type of access patterns are you seeing for the application. And then he's going to show you an overview of vCenter Operations Manager and how we are trying to integrate our statistics and health into that framework.
Great. So there's, as Milind mentioned, a lot that you can do with the NSX platform from an operational perspective. And I'm going to try to pick a few of the interesting ones and demonstrate them here. The first being flow monitoring. So this is a real-time view of packets and your TCP sessions, et cetera, that are coming out of any given VNIC. So what I'm going to do here is, again, dive into the vSphere web client. We're going to go into the networking and security tab, and we're going to go into flow monitoring and choose a VNIC of interest. So in this case, I have a test VM here, which I'm going to select. And we're going to start the monitoring of this VNIC. Now, there's some activity occurring there, and I'm going to actually go ahead and spawn a script that actually fires a few connections out to the public internet. And what we'll see here is the TCP connections are directly reflected in the vSphere web client, and you get your Wireshark style view of connections as they are active in green and connections as they terminate in red. And so what this can let you do is debug a specific application or specific application's traffic pattern if there is a suspected issue, for example. Now, but this is real time. This can also be exported via syslog directly from the host if you wanted to export it to something like Log Insight. And this will let you kind of create that historical histogram of your data center's traffic or VM's traffic or whatever your specific use case is for future analysis. So this is just one cool tool that you can use to kind of debug and troubleshoot what's going on in a specific VM.
So instant view into what's happening into your traffic patterns at the VNIC level, and then leveraging existing tools, your syslog management tools like Log Insight to get historical perspective and do root cause analysis, as you have more spare time from an operational standpoint. That's pretty powerful.
So the next thing I want to show is what Milind just mentioned. We have the ability to actually introspect within a VM's application level to see what kind of applications are being used, and then leverage that fully stateful distributed firewall and defend against bad citizens, if you want to call them that. So this is something that's available with our vSphere platform today. And when I go ahead and start this, we're going to actually just quickly dive again into the activity monitoring section here. And I have a VM here, a bad citizen, if you want to call him that. He's actually using a torrent and trying to download something. So what we're going to do is actually just from NSX Manager, we're going to actually just query to see what applications are running in our infrastructure. And right away we see that this guy here, Mr. Administrator with this UUID in his Active Directory, is actually leveraging utorrent.exe here. And we can actually then dive back into our security groups, create a rule, and explicitly block something like this. Or we can say, well, file sharing, well, we only want our domain admins to actually be able to do this. We can create these kind of rules that are both, your traditional firewall rules, blocking IPs, ports, MACs, et cetera, or kind of application level, application aware, identity-based rules in our network using the NSX platform.
Pretty cool stuff. So better visibility, like I said, from the general visibility standpoint, all the flows that are taking place. We're starting to look within the application itself and provide perspective and visibility from that standpoint, right? So that you know what's going on in your data center, both from an app perspective as well as just from a network conversation standpoint.
Right, and then the last thing I want to show here is kind of that historical view. Now there's a couple ways to do that. We can gather logs, put them into Log Insight. We can kind of check the health of our virtual network. And vCenter Operations Manager is one such tool, and this is all data that's available over REST APIs, so it can be integrated with any kind of monitoring tool that you may have in your infrastructure. And what I'm going to do here quickly is show this for some of the gateway services, right? Your interface stats, your TX, RX, your drops, some of the services, your load balancer active sessions, your firewall connections. These are all stats that can trigger alerts or provide data of interest in your data center topology. So the first thing I'm going to do here is actually drive into the logical router that we had configured earlier, and we can see kind of a real-time snapshot. And this is through the vSphere web client. But this is just real time. Now we want to export this so we can see kind of a historical view of what happened between the hours of 12 and 12:30 today. It looks like something went wrong, right? So again, using REST APIs that are integrated using a REST collector and vCenter Operations Manager, VCOps, we can actually switch over to VCOps and check the health of our network there. So we can see things like, what's the health of my gateway VM? What's the CPU resource utilization of it? What is the interface stats? What is the throughput? How many connections are active at any given point in time? This is all the type of rich data that the NSX platform can provide fully over REST APIs. In this case, using a VCOps collector. So as we see here, I have kind of my heat map, and most of the guys are doing pretty good. And there's one gateway that's not doing so well. So we're going to go ahead and troubleshoot that. So we can see kind of the topology, and we can go look into the resource utilization as well. We can see the bandwidth, the bandwidth consumption, the CPU, the memory, etc. And then we can go drill into the custom views in VCOps and see some of the custom topologies from the NSX Manager. So you see those topologies of where are my routers, where are my VXLANs, what are the port stats there. These are all types of statistics that are exported by the NSX platform. In this case here, I'm going to show the interface stats and some of the VPN, load balancer, and firewall statistics that are exported from the edge gateway device. And as we see here, there's a whole laundry list of statistics available. I've graphed out a few of them in Ops Manager to show me what was happening in that the trouble time between 12 and 12:30 today afternoon.
So again, you can monitor in many different ways. We continue to enable these different ways to do it. But I think the future is to kind of automate the operational elements, right? Not worry about point troubleshooting, but use analytics tools to make that happen. So as we enable existing tools, we continue to push the needle into how we can think about operations moving forward. Because we cannot react, we have to do proactive monitoring. And our hope is, of course, we have our own toolkit like vCenter Operations. There are other toolkits like Splunk and others. And how can we integrate with these systems to provide full and better visibility and a proactive way to monitor this infrastructure versus a reactive way? So while we provide a lot of this functionality, switching, routing, firewall, load balancing, we are a platform. And you have existing investments with existing partners. And so the natural question is, how can these partners participate in this platform? So we have already started work with a lot of these partners on this front. As an example, we are working with the switching ecosystem, whereby which you can now program a physical workload that sits on a physical switch into a logical network, right? Through the same API that we provide. The L2 gateway service that I talked about, the bridge, can be offloaded to those physical switches. We are working with Palo Alto Networks, where they are working in conjunction with our firewall to provide a better firewall, right, together, right? Advanced services in context with our firewall to provide a solution for data center firewall in your environment. For security, we have a track record of working with a lot of the antivirus vendors. We are adding vulnerability management in there, and continue to push the needle in regards to not just antivirus, but IDS, IPS, and other solutions. And there is a lot of these vendors, by the way, actually showcasing this solution at the show floor as to how they integrate with NSX. And last but not the least is application delivery services, partners like F5, Riverbed, and others, where we are actually pushing the needle, working together to figure out how we can best work and enable you in this environment. So load balancer, not just from us, but if you have an F5, can we work together? That is the plan. That is how this platform is going to be extensible, right? So again, it's one element of it. On the other side of it, we are working with other cloud management systems. So it is not a closed system. You can see Red Hat, OpenStack, Canonical. These are not just vSphere-based solutions, but even work on other hypervisors and other platforms. So think of this from a platform standpoint, and as a result, an ecosystem developing around it. The single biggest thing we keep in mind is, can we keep the automation element intact while we do so? So a quick overview on something very interesting that we've added this year around security automation, the ability to take IDS, IPS, antivirus, and all of these pieces and create what we call as a security policy. So let's take a look. You could create a PCI container, and it shows over here there's a policy that's written for this PCI container. There are two endpoint solutions associated with this container. In this case, it could be Rapid7 and an antivirus solution from our partners. And you can see there's an alert over there. So visibility into this, what's happening in this container from a security standpoint. There's a firewall policy associated with this container, again, using the firewall that we talked about before, and then an IDS IPS solution enabled. So from a security standpoint, you can create a fully automated container with conditional workflows. So what does a conditional workflow mean? Let's say you detect a virus in one of the workloads. Automatically, it will result in a conditional workflow to us, whereby which we would then put that VM in a quarantine zone. You can do these kind of advanced workflows as part of this framework that we are putting together. We are starting with security, and we'll extend this policy framework moving forward to other solutions. So putting it all together, right? We talked about a lot of these solutions. So what are customers doing with this? You heard from eBay. eBay has built a DevOps cloud to enable this, and they're also using this to onboard for M&A purposes. Data center automation, this is where customers like WestJet, they're speaking at 5 o'clock today, are simplifying how they design the interior of their data center, right? Instead of having multiple tens of hardware compute zones, they are building soft compute zones to make that happen. And then, of course, public clouds is a very important use case, but one that is used both by large enterprises as well as public cloud providers. What I wanted to leave you with is this notion that what you have with this platform is, again, across hypervisors, a fully distributed switching, routing, firewall, and services platform. Again, from a throughput standpoint, line rate, performance standpoint, something that gives you assurance that will work for your business-critical workloads. So this is for all the things you already have in your data center. But what if you are building a new pod or a new greenfield data center? How do you think about this, right? So imagine setting up the core of your network, the spine of your network, setting up the cabling, right, and setting up NSX and other infrastructure components, software components that you need for this data center. You need capacity, you roll in the rack. The switch gets auto-provisioned. This is capability in switches like Nexus 3000 and others, where you can auto-provision and load software on that top-of-rack switch. You can already auto-deploy servers today with ESX, right, and the NSX software. And then, essentially, you can do application-specific networking on demand in software as needed. And as you want to add capacity, you simply roll in the next rack. Right? It's a L3 design, leaf spine that can scale, and it's fully automated. You can just rack and roll. That is what NSX can do as you think about your data center moving forward. We covered a lot. Lots of other topics that you can go to over the next 3 days. There are hands-on labs. We're at the booth. Stop by, ask questions. Again, thank you again for attending, and we'll open it up for questions.
What the t-shirts? Here.